Okay, so today I'll be talking about my PhD research on a group of aquatic insects called Corixids and how their migratory activity connects the food webs in wetland and river ecosystems. So I got started studying Corixids back in my undergrad, thanks to a project that was given to me by Ian Phillips. And since then, I've become rather fascinated with them. Um, they're this very common but seemingly inconspicuous group of insects with a remarkable amount of complexity when you start to study them a little more closely. The Corixidae, commonly known as water boatmen, are a single family of aquatic insects with about 40 species here in the prairie provinces. They typically range in size from a couple of millimeters long to almost a centimeter in length. And to the naked eye, they might look like small beetles. They have these two hind legs that stick out kind of like oars, giving them their name. And they can be found in almost all types of aquatic ecosystems. They typically prefer standing or slow moving water and reach the greatest abundances in macrophyte dense fishless habitats. As far as their diet goes, it's all over the map. On the whole, the family is omnivorous, with some species relying more on algae and detritus, others acting as predators or employing multiple feeding strategies. And they typically produce between 1 and 2 generations per year in temperate waters, although this can vary depending on species and climate. Another interesting feature of the Corixids is their ability to fly. They fly readily at night in the summer, and you've probably seen them around your porch lights as they're very attracted to light. They especially like black lights, like this trap that I have running in my backyard over the summer with a converted mosquito zapper with the zapping parts taken off. There's a lot of uncertainty as to just how far they can fly, though, with literature estimates ranging anywhere from a couple of kilometers to almost 100 kilometers per day, with wind potentially playing an important role in the distance and direction traveled. Corixids also undertake pulsed seasonal migrations in spring and fall, moving from breeding to overwintering habitats and back again. In northern latitudes of North America, these fall migrations are likely driven by the imminent freezing of small, shallow habitats, many of which will freeze all the way down to the bottom, and in which a lot of species like to breed in. These Corixid species will then fly and gather in large, deep bodies of water to overwinter, such as rivers and large lakes. In rivers in particular, there are records of these migrations resulting in very large concentrations of Corixids. But the overall ecological importance of these migrations is not particularly well understood. So before starting this project, we had observed large Corixid swarms in both the North and South Saskatchewan rivers, and we now know them to occur in rivers throughout the Canadian Prairie Pothole region, or PPR. But the exact scale of this flux, how much it changes the abundance of Corixids in rivers, what species are involved, and just what the magnitude of this flux is on a greater scale is largely unknown. A number of fish species have also been shown to prey on Corixids, but whether or not these migrations increase that importance has not really been explored. So we set out to answer these questions while also looking into what we believe to be the driver of these migrations, overwintering conditions in wetlands. So my study area is in southern Saskatchewan, centering around Saskatoon, where I collected samples from sites in both wetlands and in the North and South Saskatchewan rivers. My wetland sites were mostly roadside ponds bordered by gravel roads and agriculture. And my river sites were areas of standing or slow-moving water along the river edges, often near backwaters or ferry embankments, or in large stillwater areas created by things like beaver lodges. I collected Corixids from these habitats by performing sweeps with a D-frame net along 5-meter transects at depths of about 30 centimeters to a meter deep, perpendicular to the shore and wetlands and parallel to the banks and the rivers. And fish were collected from sites in both the North and South Saskatchewan rivers, mostly by gill netting, and their stomach contents examined before and during times when large numbers of Corixids were present in the rivers. So during the years of this study, the Corixid migration into the rivers got started in early September. Just a few landing here or there, slowly at first, but then towards the end of the month, on warm, sunny days, usually from late afternoon to early evening, they can be found just raining down from the sky in swarms. It's very exciting to be standing in the middle of this Corixid rain. Uh, the timing of these landings is it could be because of when the optimal reflection of polarized light occurs off of the surface of the water, as this is thought to be how the Corixids locate new habitats from the air. Back in the wetlands, during the fall, the Corixids can be seen taking off directly from the surface of the water if it's warm enough. But if it's too cold or if it's getting late on in the year, if there's even a brief period of warm, sunny weather, what they'll actually do is climb onto the banks or onto emergent or floating vegetation, and they'll warm themselves in the sun for a few minutes prior to takeoff. So this lets them enables them to migrate quite late into the fall if there's even a brief period of warm, sunny weather. And once the migration gets going, the change in the rivers compared to a few weeks prior is remarkable. Wherever there's standing or slow moving water and any kind of structure like sticks or rocks, you can find these dense black swarms of Corixids, sometimes extending in a band along the entire bank. For example, this is a picture of the South Saskatchewan River in fall. And if you look closely, you can see that there's this thin black line along the bank here. This is actually a solid band made up entirely of water coat. And if you're to take a D-net through one of these areas, you can very easily end up with a sample that looks like this. The Corixids actually have a scent to them, which is the result of a special secretion that's thought to have either antimicrobial or anti-predatory properties. But you can actually smell it if you pick up a handful like this and hold it right up to your nose. I think it smells quite pleasant, almost a bit citrusy. So this brings me to my first objective, which is examining how these migrations change the number and species composition of Corixids that are present in the wetlands and in the rivers. So this graph here shows the adult Corixid abundances and all of the 5-meter D-frame nets in my different sites, with the wetlands in gray and rivers in white. You can see that in the summer, numbers are fairly similar in both habitats here. And sorry, this is throughout 2015 and 2016. So you can see that in the summers, numbers are fairly similar, but then in both years, they tended to decline in the wetlands, moving into the fall, as the Corixids either migrated away or died off. And then in the river sites, numbers mostly skyrocketed in most of my sites, when you could commonly get thousands of Corixids per sweep. Numbers were also quite high at Icebreak here in April of 2016, but then rapidly declined as the Corixids migrated back into the wetlands to start the process all over again. Just to give you a glimpse of the spring migration, the Corixids start to leave as soon as the river ice breaks up, swarming onto the banks, or even taking off directly from the surface of the ice if it's warm enough. At this time, they can also commonly be found stopping over in meltwater puddles or ditches on their way to deeper waters, or if the wetlands are still frozen over at the time of ice break on the rivers. So with this migration between the habitats, there's also a very distinct shift in species composition. So to give you a snapshot of that, in 2016, here, these are the proportions of the different Corixid species that were present in my river sites in August and November of 2016. So you can see that here in the left, in gray, these are the mostly non-migratory species that appear to live and breed in the river all year round. But then in fall, these river residents become vastly outnumbered by an influx of migrants here in color on the right, namely Sagara bichloropennus, Callicarixa odini, and Sagara decoratella. And this is a snapshot of what the wetlands typically look like in summer and in fall, where you can see that those migratory species can be readily found here in their breeding habitats in summer, but then they pretty much vanish by fall, having moved into the rivers. I should also note that this one species here, Trichocorixa verticalis, it appears to be fairly unique among most corixids, or possibly even other species of the Trichocorixa genus, in that they don't migrate and they don't overwinter as adults, but as eggs. So the adults actually lay their eggs in the fall and then die off. So then these corixids leave behind species such as Semacia americana here, which is really interesting because it doesn't migrate, but actually appears capable of spending the winter encased in air bubbles within the ice. So I'll get into that a little bit more later on in the talk. A problem with D-frame net sampling is that I did my sweeps in areas of little to no flow. And the numbers of corixids that you get in a net sweep can really vary depending on whether or not you hit some structure with one of these dense clusters around it. So these conditions obviously aren't continuous down an entire stretch of river. So it doesn't really work to apply that to a length of river to estimate the abundance of corixids over a greater area. So what I wanted to do was to develop a less biased approach to measuring the migratory corixid inputs that could be applied to a greater area to get a sense for this flux over a certain stretch of river. So to do this, I developed a highly sophisticated passive sampling method, which consisted of a bucket duct taped to a piece of rebar with a funnel on top. I later upgraded to a design that was attached to a PVC tube so that it could float up and down if the river level changed. I lost a few samplers before I adapted that new design. The corixids would simply hit the funnel and land in the bucket as they attempted to enter the surrounding water, as their aim didn't seem to be very precise. So in 2017, I set out 24 of these samplers over 4 sites in both the North and South Saskatchewan rivers, with 6 samplers at each site, 3 on each bank, and I set them within about 1 to 2 meters of the main banks. The reason for this is that when the corixids are entering the rivers, they actually seem to concentrate their landings almost entirely to this area along the main banks. I observed very few, if any, actually landing mid-channel. We think that this might be an adaptation to end up near areas of standing or slow-moving water, or possibly to avoid fish predation. So I left the samplers out for the entire migratory period that year, right up until when it began to ice over, and emptied them as often as I could. So in total, those 24 samplers collected just over 70,000 corixids, which works out to an average of about 3,000 corixids landing per square foot. Or if you extrapolate that into per meter squared values, to just over 40,000 Corixids per meter squared. Or with a corresponding biomass value of about 500 grams of Corixids landing every square meter along the edges of river margins during that migratory period. So this figure here shows the weekly collection rates in all of my samplers at each site. And you can see that the majority of the Corixids fell in pulses, with numbers slowing down if you got a week of cool, cloudy weather, and then also tending to decline as you move later and later into the fall. To give you an example, I was working on the river one day when the Corixids were migrating into the water like this. And I set out this little about foot by foot sorting tray just in the edge of the water here while I was working. And in the course of about 10 minutes, these Corixids landed in here. And there's actually about 650 Corixids that landed in that tray within that short period. So even when these migrations occur sporadically, over the course of a month or two, it isn't hard to imagine that you could get some pretty large inputs occurring along rivers throughout this migratory period. So this brings me to my next objective, which is extrapolating these findings to a larger area to estimate what this Corixid flux might be across the landscape if what we saw in my little study area is applicable to a greater area. So the prairie pothole region where the study was carried out is a large freshwater wetland complex in central North America, estimated to contain millions of wetlands. And this is my little study area here in this box in red. And so what we did is we took the parameters that we found in our passive samplers and ran some simulations to estimate what the Corixid inputs could be into rivers if they were to receive a similar amount of Corixid material as what we have observed in here. So we drew from random numbers between 8,000 and 135,000 Corixids per meter squared, based on the lowest and highest numbers that we collected in our passive samplers, with a weight range of between 2 and 20 milligrams per Corixid. The weight range of the largest and the smallest of the potentially migratory species that we observed in the study. And then this can be applied to the length of both banks of a particular stretch of river. So if we apply these numbers to the length of both the North and South Saskatchewan rivers within Saskatchewan, from the Alberta border to the confluence, to the length of both banks, it generates a median estimate of about 1,500 tons of Corixid material, ranging from 40 to over 7,000 tons. I've observed similar Corixid migrations as what we saw in here, from the Alberta border all the way to the confluence of the two rivers. And we also have observations of this happening beyond as well, in the North Saskatchewan River in Alberta. I've also observed the mass fall migration happening in the Red River in Manitoba. And we even know that these migrations occur well beyond the prairie pothole region. Also in North Dakota. There are literature records, but also beyond in Wisconsin and well into the boreal as far north as Alaska. So this Corixid migration phenomena, it really is something that occurs both throughout and well beyond the prairie pothole region. Now, if we were to apply this simulation to multiple large river systems within the prairie pothole region, it generates a median estimate of just over 12,000 tons of Corixid material. Now, this isn't all of the rivers in the prairie pothole region, and Corixids also migrate into lakes and smaller streams. Although I don't know if it's with the same intensity as it is in rivers, or Corixids aren't as concentrated. This is a bit of an unknown for me, as we focused largely on just the two large rivers here. Now, we can also go the other way and estimate the number of Corixids that may be poised to leave PPR wetlands in fall. So in our D-frame net sweeps, we collected an average of about 10 to 20 individuals of the migratory Corixid species per meter squared in the months prior to fall migration. Now, converting DNet sweeps to per meter squared values is very rough, as it doesn't account for the entire water column. Also, my sweeps were taken on the periphery of wetlands, which, in small, shallow wetlands that are fairly uniform in terms of depth and densely vegetated throughout, these numbers might be applicable to the entire wetland, but in sites that are larger with open water sections in the middle and they're deeper, these numbers might not be so applicable. But bearing those caveats in mind, we ran a simulation with those numbers and the same weight range of Corixids with a wetland area anywhere between 5 and 12 million hectares for the entire prairie pothole region. This is prone to a lot of fluctuation, and in wet years could be much higher than this, but we just limited it to that for now. And what we found was an estimate of also about 12,000 tons that could be poised to leave wetlands in the fall, similar to our river input estimates. Again, these are incredibly broad estimates, but it's a place to start assessing the true scale of this flux across the landscape, at least in the prairies. However, just because the Corixids are entering the rivers in fall, they don't all stay there. Many of them migrate back to the wetlands in spring, except for those that die in the rivers. So it's more of a redistribution of wetland productivity via Corixids across the landscape, with a stopover in rivers along the way. But it would appear that there's at least one means by which the Corixids enter riverine food webs through fish predation. So that brings me to my next objective. For those fish that fed heavily on Corixids in the fall, there was goldeye, mooneye, long-nosed sucker, and white sucker. For the goldeye and mooneye, they displayed a very strong shift in diet from relying on crayfish and a mix of aquatic and terrestrial insects in summer. This one here had eaten crayfish and grasshoppers and dragonfly adults. I even found one with a rodent jaw in its stomach. They'll eat just about anything. But then they shift to almost entirely Corixids in fall in the individuals that I sampled, with Corixids accounting for over 75% of the weight of all of the stomach contents and occurring in all of the fish. What was interesting was that those that weren't completely full of Corixids were full almost entirely of Dytiscids, or predatory diving beetles, or nodonectids, also known as backswimmers. And these insects also migrate from external habitats like wetlands, much like the Corixids. So it's interesting to see that these two species are shifting to almost entirely external subsidies in the fall. They also appeared to be eating more in fall, with stomachs that were over twice as full on average. These fish were eating Corixids during the summer months. They occurred in most of the individuals that we sampled, but it was a negligible amount of weight, maybe a couple of pieces here and there. As for the suckers, the long-nosed sucker that I sampled were all completely full of Corixids. They could fit thousands of them into some very long digestive tracts. I hope you all enjoy looking at pictures of fish guts. I know I do. With the Corixid material in the stomachs, the head capsules seem to pass through relatively intact. So by picking these out, I'm able to count and get a rough estimate of how many Corixids they can pack into their digestive tracts. The white sucker were a bit more variable in their feeding habits, often relying more on a mixture of other invertebrates such as mussels and snails, represented by shells, Trichoptera, or chironomids, or all sorts of materials, really, which also dominated the diets in summer. I sampled 3 sucker species, these two and shorthead red horse. However, I never found a single Corixid stomach in any of the red horse at any time of year. Their diets and feeding modes have been reported to be fairly similar to other sucker species, so it's interesting that this one doesn't appear to eat Corixids, and I currently don't have an explanation as to why. As for the walleye and pike, I only found a couple that had a small number of Corixids in their stomachs. Mostly they appeared to be relying on fish or other invertebrates. However, I found several that had small fish in their stomachs, which had Corixids in their stomachs. So Corixids inside of small fish, inside of bigger fish. Despite being quite degraded, I was still able to pick out little digestive tracts from some of these prey fish. So it appears that there's at least an indirect importance to these top predators through feeding on other fish. My attempts at seining and minnow trapping weren't too successful, so I have yet to adequately assess the importance of Corixids to the diets of these smaller fish species. Let me see here. There we go. So there are a number of effects that Corixid migration could have on fish communities and rivers. For one, they appear to be of direct importance, particularly to the diets of generalist invertebrate feeders. There may also be indirect effects through interactions with riverine and invertebrate communities. For example, I found a number of walleye that had been feeding very heavily on gomphid dragonfly nymphs, or this one which had also eaten Hexagenia mayflies, or this one had eaten a pteronarcid stonefly and I think what was a burbot. And then inside the burbot were these heptageneid mayfly nymphs. I wouldn't be surprised if there weren't at least predatory interactions or maybe even competition for space between the Corixid swarms and other invertebrates. At the same time, there could also be a form of apparent competition going on here, where if you have fish species that are able to exist in greater abundances because they're relying on this external subsidy, then in years when the Corixid subsidy might not arrive in as large abundances, or when they migrate away, these fish will shift predation pressure back to resident invertebrate species. At the same time, the Corixids are also indirectly important to these top predators, transferring wetland productivity into secondary production of fish in the rivers. There's also the possibility that the migratory Corixid subsidy is being used by consumers beyond just fish. I saw a number of riparian spiders in spring that would nab Corixids as they were climbing onto the banks in preparation for their spring flights. Or one day I was walking along the river and I noticed this piece of scat, and there was a little red dot that caught my eye, which is actually a parasitic mite on the back of a Corixid. The Corixids they're quite plagued by these mites. So I picked this apart, and yeah, it was full of Corixids and fish scales. I don't know what it would have been from though. Maybe a mink. I'm really not too certain. And then there's the likelihood that this migration is also subsidizing the diets of different bird species. I have found both evidence in the literature. I've received a lot of anecdotal evidence and seen ducks and gulls feeding on areas where there are large swarms of Corixids in the river. And the Corixids are also fed on by aerial insectivores throughout the year, like bats and birds. Mercy Harris was kind enough to share some of her results with me, where she found that they're being preyed on by swallows, which is just some fascinating work that she's up to. And then the Corixids are also fed on by vertebrate and invertebrate predators in the wetlands themselves, such as this Dytiscid larva here. So the Corixid flux may be fueling consumers in a variety of habitats across the landscape. So why these migrations in the first place? We believe that wetland conditions over the winter may be the driver for these mass migrations. So while so many Corixid species seem to vanish from the wetlands in fall, there's this species here, Srayko americana, that does not migrate. And then there are some individuals of otherwise migratory Corixid species that can still be found in the wetlands at fall, at ice over. So if the Corixids really do need to leave, then why are they still there in many of the wetlands that will freeze completely through? I would have been very confused as to what was going on here if it was not for the work of another student from the U of S, Jordan Mihalix. In Jordan's undergrad, he did a study where he thawed out some pond ice and had a look at what came back to life. And what he found was a cluster of Srayko americana frozen into an air bubble in the ice, most of which came back to life on thawing, in addition to a single individual of another species that didn't survive. There's practically no record of this overwintering strategy in the ice for Corixids in the scientific literature that I've come across, short of some records from the 1920s and a couple of records that I found for different species of Srayko in Europe. So Jordan, he found something really fascinating here. And I'm riding on his coattails, trying to see what this means for the Corixid migration. So I set out to determine if there are any other species that can survive by freezing into the ice in this way, and to assess the mortality rates associated with this strategy. If they don't actually need to migrate, then something else could be at play. So we examined the overwintering of Corixids in 3 wetlands near Saskatchewan from 2017 to 2018. Just as the ponds were freezing in 2017, guaranteeing no more migration, we threw on our neoprene waders and collected Corixids from just under the ice to see what was there at the start of winter. And what we observed was that air bubbles were already forming in this very thin layer of ice. Some of them that were still open to the water from beneath. So what you're seeing here in this picture and this video is this chunk of ice here that we cut out and flipped over. And it was neat because these bubbles were already starting to accumulate Corixids. Whether they were entering them by accident when they were skimming along under the ice or on purpose, I can't really say. But then this is what those bubbles look like full of Corixids when the ponds are frozen through midwinter. So then in late winter, we went back. We cut out these large chunks of ice from the wetlands, chipping down to the sediment, and then hauled them back into the lab. There we carefully cut them apart, noted where the Corixids were in the ice column, and then took these small chunks and thawed them out in a walk-in cooler at about 6 degrees Celsius. Once the Corixids were free of the ice, we moved them to room temperature, about 10 to 15 degrees Celsius, and watched for signs of life for up to 48 hours. So these graphs show the proportion of each species that we found under the ice at freeze up and then within the ice chunks. So there was a range of species that were present under the ice as the wetlands were freezing over, but then within the ice, we really only found Srayko americana and this other species, Dasycorixa hybrida. Overall, mortality was extremely high, with only Srayko showing signs of revival. Most of them were frozen together in these clusters in air bubbles within the ice, with fewer frozen singly. Only those that were in bubbles survived. Anything that was just frozen into the solid ice didn't make it. Everything was also frozen in the top 6 inches of ice, so there wasn't really much to test in terms of depth, even though most of these blocks were about half a meter deep. In a preliminary sampling in early on in the winter of 2017, the deepest cluster that we found was about 8 inches down here, of which about 20 out of 100 Corixids revived on thawing. So while it seems unlikely to me that the Corixids could tolerate internal freezing, they may be able to avoid freezing with the use of antifreeze compounds, perhaps like glycerol, or perhaps by avoiding prolonged contact with the surrounding ice. This is speculation, but maybe by freezing into a cluster, if you can situate yourself in the center and shield yourself from prolonged contact with the ice from your cohorts, maybe that could help prevent ice inoculation throughout the winter. Temperature did fluctuate a lot in the winter of this study, and there was uneven snow cover on the wetlands that we sampled. So perhaps exposure to extreme cold after warming somewhat was what resulted in such high mortality. Then again, maybe there was some aspect of our thawing procedure that also caused a lot of this death. However, I went back to one of the wetlands that we got most of our Corixids from in spring. And what had happened that year is that there was some very rapid snowmelt, such that it actually flooded the still frozen pond underneath. And then Corixids that were frozen near the surface were gradually getting liberated, floating to the top. And I went there on this very windy day, and all the Corixids coming from the wetland were being blown to the side and whipped up in this foam. And it was just jam-packed, full of Srayko americana, the vast majority of which appeared to be dead. You can tell that they're Srayko because they have this very distinct greenish color, which is pretty unique from most Corixids. I took a random sampling of these and brought them back to the lab. If you can see this video here in this sorting tray, you can see the ones that are alive are moving around there, and everything else was dead. So perhaps what we found was actually an accurate representation of the mortality that naturally occurred within the ice. Something else that was interesting to note was the other insects that we found within the ice. The Corixids weren't always frozen alone in their bubbles. We often found these haliplid beetles that revived on thawing with them. There were also damselfly nymphs and phrygineid caddisfly larvae that were frozen solidly into the ice, some or all of which revived on thawing. I found no mention of this strategy for haliplid water beetles, short of Jordan's work, or phrygineid caddisfly larvae. So it's possible that this represents a fairly understood strategy for certain aquatic insect taxa. So as far as we can tell, Srayko americana is the only species of Corixid that can overwinter in this way. I have some suspicions that Dasycorixa hybrida might be able to as well, but we got some very low numbers of those, and none of them did revive in the current study. And so all of this would point to that these individuals that are still stuck in the wetlands at Iceover are there by accident. They simply didn't manage to get out in time, or it's possible that they may be flightless morphs. Many Corixid species have these flight-incapable morphs, which might give them a reproductive edge if they hatch out in a wetland or a body of water that remains permanent throughout the year. And overwintering conditions could have implications for the prevalence of different Corixid species in certain habitats across the landscape. You know, maybe in some years the Srayko in the wetlands do better than the ones that migrate, or maybe the ones that stay in permanent habitats all year round have an edge. So that brings me full circle into my investigation of just some of the aspects of this migration. As of this past year, almost all of the wetlands that I looked at several years ago, starting several years ago, have since dried up. And many of them have even started to become vegetated throughout. Or then this one wetland here at the edge of Saskatoon no longer exists. It's been completely filled in. It had a fairly unique species assemblage there too. And yet every year I go to the rivers and the migratory Corixids still show up, although I haven't been measuring it throughout, so I can't speak as to the exact strength of this flux from year to year. With more small wetlands drying up or being drained or filled in, I do wonder what will happen to a lot of the species that rely on these habitats. And yet wet dry cycles are certainly a part of the prairie climate. And the aquatic Chemiptera that we have here are thought to be pretty adaptable, overall ecological generalists. So we'll see what the future has in store. Until now, I never would have thought of small prairie pothole wetlands as in any way being connected to distant rivers, but this transfer of insect material means that these ecosystems don't exist in isolation from one another. In addition to the many ecosystem services that we already know wetlands provide, another that can certainly be added to this list is the export of important prey subsidies to external aquatic food webs, and terrestrial as well. And while they may not be as conspicuous as wildebeest or salmon, the seasonal movements of these insects between breeding and overwintering habitats across the landscape, collectively, it really does represent one of North America's great migrations. This linkage underscores the need to conserve both wetlands and rivers together as much as possible to ensure that this connection is maintained. With that, I would like to thank my supervisors and committee members for their support, as well as my lab mates and many other people who have helped me out, especially my ice haulers here. They worked very hard. And we recently published some of the results that I talked about today. If you'd like to check out the paper or give me a shout, and I can send that your way. Thanks again.